Hi, today we're going to do a video on how to change the head gaskets on a small block Chevy TPI engine, which is a tuned port injection engine from around designed around the 1980s. It happens to be in a Landrover Discovery. Now, this is a conversion by Overfinch, but this head gasket job should be applicable to a lot of different mainly American cars, Corvette, Camaro and other cars. So the first thing you've got to do is disconnect all the ancillaries. So this car also has LPG gas injection in addition to the normal petrol injection. So here are the LPG injectors. So it adds to the complication of removing all of the ancillary components. So some of that won't be applicable to your engine, but hopefully you can use some of the information in this video to help you change the head gaskets in yours. So what I'm going to do is change the head gaskets to the more high performance multi-layer steel type, which I think should have been used in this engine previously, and instead it had the normal Velcro non multi-layer steel, some sort of I'm not sure what material it is anyhow. So hopefully the new multi-layer steel gaskets will be much better performance. So the problem at the moment is I have a slight I think leak from the combustion chamber to the coolant system, because there's a lot of steam coming out, and one of the spark plugs, the left at the back there, is very clean, which are much cleaner than the other ones, which indicates that there's a lot of water getting into the combustion chamber. If I have time, I might try and do a combustion test as well, just to prove which cylinder is actually the problem. So first of all, let's get all those ancillary components off. So first we remove the intake trunking. Put that over to one side. And next we want to drain the coolant out of the engine by disconnecting the bottom hose on the radiator. It's a bit tight on this one, so I might take out the fans first. That's the fans lifted out of the way, and a useful little tip to get that Jubilee clip from the bottom of the hose is to get a socket. Most of them are 7mm. There's some extension pieces on it, and then you can quite easily undo it from the top with a lot more room to manoeuvre. So undo that bottom hose and let all the water drain out the engine. Obviously you have a bucket underneath to collect all your antifreeze. And next we'll remove the belts driving the alternator and air conditioning, power steering pump and so on. So you just need to get a spanner on this idler pulley, release the tension on it by pulling it down, release the belt, and then release the pulley again. Actually, we'll release it from the top. It's going to be a little bit easier. There we go. And then the belt will remove like so. Might be useful to take a picture of it so you know how to rethread it. That's the belt off. And then to make things easier, we'll also remove the alternator. A couple of bolts here. And to make it easier to clear the alternator, the intake plenum needs removing, and we'll do that by loosening up these bolts that connect the intake tracks onto the plenum chamber either side, so evenly all the way around, and then the whole chamber with the intake throttle body should come off as one whole unit. I'm hoping we can just put that to one side and leave some of the other connections connected to it, such as all of the throttle cables and connections to the automatic gearbox and so on. And then just to make life a little bit easier, we'll actually remove the cable which connects to the automatic gearbox. There's a nut in there which I've undone enough. Pull back the boot, unscrew the nut, and you should be able to push the body of the cable backwards such that the cable fits down the slot, and then you can detach it like so. I'll just pull that back out of the way. There's a little clip on the hose that needs removing at the back there in order to fully release it, but most of it is now released. and we'll just do that and lift it out of the way. And that's the plenum chamber with throttle body lifted away. You might find in your car you have water hose connections to the throttle body. On this car they're disconnected. If you do, just obviously disconnect them. Then disconnect the battery, and we can lever the alternator out of the way, like so. So there's only these two long bolts here need to be removed. Give it a bit of a wiggle. These two connections here we're going to have to remove. So let's just make a note of which way around they're connected and what it says on these. And the air conditioning pump needs to be disconnected from the cylinder head, and the easiest way is just to undo the 4 bolts that hold it in place onto this adapter block, leaving the adapter block connected to the cylinder head so that can come off as one unit. It looks a bit tricky to remove it, otherwise it's difficult to get to some of the bolts. And then start removing various pipes, heater pipes and so on, to free up the connections to the head. So we've got a heater pipe and another one to the pump at the bottom after having done these Jubilee clips. Put those to one side, and similarly onto the inlet manifold. That actually goes off to my LPG system to heat the evaporator. And then the next thing we just need to do, because ultimately we're going to have to remove this intake manifold. See, he's got these star embedded bolts that hold the manifold onto the head. Similarly, these bolts here that hold the intake tracks, so these bolts have to be removed. To get to them, the thermostat housing has to be removed, with in this case it's got like hex key heads, so you need a little adapter socket like this. So we'll next remove that, take off the inlet tracks, and I'm not going to detail removing every single wire and pipe on the engine because quite a lot of them. Needless to say, if you do remove the wire, take a picture or label it up to show where it goes to. This one's a bit more complicated because of all the extra wiring for the LPG system. So that's why I'm not going to go into too much detail. And I think we'll also take off the rocker covers, which have got to come off eventually anyhow, but that might, I think, give better access to these bolts on the intake track. So there's I think one either side of the pair of intake tracks, which you'll see if you have a look around there. Basically a bolt there, one in there, and one on the other side that you need to remove to take the intake tracks off. So there are 5 bolts to the right hand side of the intake tract that need undoing, and one awkward one is worth mentioning. There's a little bolt in there with a 1/2 inch head or 13mm, which has to be got from the inside underneath the plenum. It's just where my finger is pointing there. Let me just get the camera around so we can see a bit better. There we go. So that one there. You can just about get an open-handed spanner on it to remove it. And then with a bit of wiggling, the intake tract can be removed. Just got to wiggle it around the remaining cables and pipes and so on. There we go, and that's that removed. So here you can see where the bolts are. So we've got 3 that side and another 3 holes that side, so it's 5 bolts from the outside and 1 on the inside. These are the outside bolts with a star T40 type attachment. You need to undo them, so this is the sort of arrangement that I've used. Remove the spark plugs if it's just going to undo the exhaust manifold, and just pull it away slightly, otherwise the spark plugs won't clear the manifold. The alternative is to completely remove the manifold by undoing the bolts at the bottom. To get the spark plugs out, with these tubular manifolds is a little bit tricky because of the clearance between the spark plug and the manifold. and it's handy to have one of these quite thin tube ones, which you can just about get onto the spark plug through the clearance. These slightly fatter spark plug removing tools, just a little bit too fat at the end to remove it. And similarly for the intake tracks on the other side of the engine, 1 bolt on the inside, 5 bolts on the outside all the way along, all different lengths, so try and keep them in order, and then we should be able to just break the seal. There we go, and get this one out of the way as well, like so. Next thing is the need to isolate the power steering pump from the cylinder head. So there's 3 bolts, one here, which I've undone, and one right underneath, just about, see, it's undone there. And all those undone, you can see it's now detached from the cylinder head. So we can just rest that to one side. Next, to remove the inlet manifold, we've got 12 of these sort of bolts, which has got a star type T45 type recess in it, and so this is a sort of tool that's useful, and they have to be undone in a certain sequence to minimize the stress on the manifold. And if we look in, this is Haynes manual, similar manifold, not exactly the same, but it's for Camaro, the LT1 engine, I think. So you can see this is the tightening and untightening sequence, so it basically works from the inside out. So undo each bolt 1/4 of a turn until they're slack, and then you can undo them all. So started on the middle ones, now working my way out. So you can see here with the bolts, just undo those 1/4 of a turn, something like that, and then move on to the next one, and so on until you can remove all of the bolts. And then I think we're going to have to lever up between this stud sticking out, maybe the top of the water pump or something, just to break the seal around the manifold. So I want to do that just to lift the manifold to one side, to quickly take off the head, just to check what size of bore we've got so we can order the correct gasket. Eventually we're going to have to undo all these connections, so I need to label each one to make sure that they go back in the same order in order to fully remove the manifold. So that's all the bolts removed, and then we'll just wedge under here to break the seal and to then lift off the manifold. And what we'll do is just push that to one side for a moment. Then that should give us enough clearance to actually remove that cylinder head, and I'll disconnect all the gubbins later. The push rods need removing, so these nuts need undoing, just so sufficient room that you can rotate the rocker to get to the push rod, lift the push rod out, and you need to store these in the same order that they came out, so useful to mark up a bit of cardboard like so, so you can store them all in the correct order. Now that everything's been removed from the head, we can undo the head bolts and remove the head itself. So we need to undo it in the opposite order of the head tightening sequence, which is this. So in reverse order, undo each bolt with a 1/2 inch socket, 1/4 of a turn at a time, going around that sequence until they become looser, and then you can remove all of the bolts, and then we'll lift the head off. And they say to keep the head bolts in order. I'm not quite sure of the reason for that, can't see much of a reason, but anyhow, it's a useful way of storing them, to stick holes in a bit of cardboard and store them along with the push rods like so, number or more. And then hopefully with a bit of a heave ho we can lift off the head. So I think we'll use a couple of rockers, give it a pull, and there we go. That's the head removed, and put it down on a piece of card, let the oil drain off it, and there we go. And that's the head removed. Then inspect the surface after cleaning it up for any signs of where it might be leaking. or any problems. And this is the surface of the block, so again that needs cleaning up. Now we can measure the size of the gasket that we need. One of these calipers is quite useful for measuring the bore. Just slide that inside, push it to the outside edge, lift it out, and you can then read off what size it actually is, which is near enough bang on 4 inches. So now I've got all the wires labelled up, I can disconnect all the cabling to the injectors, to the dummy injectors for the LPG system. The LPG pipe here I can still leave on because that can come off as one whole pipe unit. We have to disconnect the fuel feeds to the fuel pressure regulator. So there's one at the back they've already done. Just this final one to do. Get a tissue underneath it to absorb any fuel coming out. And then should be able to remove the inlet manifold properly. So as I say, just to reiterate why we left it on in place. Normally I think you would move the inlet manifold port before removing the heads, but I wanted to get the head off quickly just to check on the port sizes and the inlet size to make sure I can order the right gaskets for those, and check on the gasket size for the head as well, thickness, bore diameter and so on. So I think everything is now disconnected. I believe I should be able to lift this all off as one unit. There we go, that's the whole inlet manifold off. So I'm just about ready to take the other head off. See, I've got all the cables out of the way, and actually I had to undo this bolt to detach it from the head. Pull that away slightly, and it's now ready to lift off. Actually I was able to leave the manifold in place, just obviously disconnect it, pull it back from the head, and just about had enough clearance to get to those bolts. So that's the other head. So having a look at the head gasket, and the whole reason for doing this job, we can see the edge of the gasket is actually corroded away there, in between the combustion area, and this is an oilway. Might have also leaked across to the waterway, which is right next to it. Possibly why it was losing a little bit of water as well, why it was occasionally misfiring. So next time we're going to put on a higher performance gasket. So that old gasket was a composite type. It was a Felpro one, reasonable make. But the next one's going to be a multi-layer steel gasket, a much more modern design type that looks like this gasket here. This is from a company in America via eBay, reasonably quick shipping. Survived here okay as well. So you can see it's metal with a little sort of black coating on it. Helps it seal, I believe. Multi levels of, in fact, yeah, it looks like 3 levels in total. They say multi-layer steel. Possibly the middle one's aluminium, therefore a bit softer. Certainly the outer ones feel like steel. So this type is actually popular that I've seen on other engines. MG Rover I've done quite a few of. They say it's a much better gasket, and I think it's used by, this type is used by quite a lot of different companies. That they sell this one as being a higher performance gasket, so there's none of the composite type material in there. You've got to make sure the head is scrupulously clean to get a good seal. Composite obviously a bit softer, probably seals a little bit easier, but to help this seal, you see you've got all these raised areas here. But they do say the head's got to be scrupulously clean, so what we'll do is clean it up and put some, well, rub it with some degreaser as well, so that the gasket seals nicely onto it. On hose, that'll then fix the problem. Okay, so here are both of the cylinder heads. I've had them lightly skimmed, so about 3 thou of each head, just to really clean up the surface from very slight grooving from the previous gasket. Makes a nice clean surface. Give them all a wash off, degreased the heads as well, and I've cleaned up the surface of the cylinder block, and this is the new gasket put in place. A little bit of a tight fit getting them over the dowels, but with a little bit of shaving of the hole, that fitted well. So hoovered out any crap around there, blown it with an airline, and decreased the surface as well to try and get a good seal with this new gasket. Because the all metal ones, I've heard, are a little bit more sensitive to sealing for water and the like, so degreasing is probably a good idea. And now to fit the cylinder head. So also clean up your cylinder head bolts, make sure you haven't got any sealing compound or anything on there. And also, if you've got a tap and die set, of course it's useful for cleaning out the holes and cleaning the bolts. If not, just put a bolt into the hole, in and out lots of times until it is reasonably free moving. That's to ensure that when you're measuring the torque on tightening the cylinder heads, that some of the torque is not due to just the friction of the bolt inside the head, and it's actually due to the torque required to tighten the head down. Alright, that is the cylinder head, or one of them, in place. So now we just finger tighten the head bolts. Before we do that, we need to put some sealant on them. So this is Loctite 572 thread sealant, which is good for sealing the threads, because some of these bolts go into the water channel, so it's good to seal off the thread, and is recommended. In the Haynes book they mention Permatex number 2, which is I think it's like a gasket making sealant. I think this one, being a thread sealant, should be better. So go over the threads as so. Don't leave it too long before finally tightening up the bolts in case this sealant sets. Screw them in hand tight first, and then gradually tighten the bolts according to the tightening sequence, which is here. This is the tightening sequence for this sort of engine, the first generation 5.7 litre small block Chevy and TPI engine. So you can see by the numbers. So gradually tighten each one. Just going to increase the torque by about 10 pound-foot on each tightening. Go through the whole sequence, then increase it by another 10 and so on until we get to the final torque, which is, let's have a look, cylinder head bolts. So 95 and earlier, 65 pound-foot. So I haven't got particularly expensive torque wrenches, but I've got one that's a clicky one and one of the bendy bar sort. Of course, being a bendy bar, it never really goes out of calibration because it's all down to the physics of the bar. This one can go out of calibration because the spring gets compressed, and the clicky bit, which is in the end here, can get a bit sticky. So it's useful to compare the two when you tighten a nut to make sure they're still in agreement and probably likely still in calibration. If you want to calibrate your torque wrench, have a look at one of my other videos. So this is a die for cleaning up the bolts. Just either with the retaining tool, or you might be able to do it hand tight, go down the whole bolt length to clean up all the rubbish that's on there. If you haven't got a tap and die set, then just using a blade like this, a Stanley blade, Stanley knife, you can basically just run it down the threads. You can see that it removes the old sealing compound from the threads, and just as good as using a die to do it. I was a bit stubborn, go backwards and forwards a few times. But you can see, well, if I stop there, it's half and half. See the difference between being cleaned out and not cleaned out. Give it a blow off as well, and get any extra bits that you miss. You can see those because in this case it was previously done with a white thread sealing compound. So to the right is done, left not done. Okay, that's both cylinder heads bolted down and correctly torqued up, and the next thing I'm going to do is reinstall the exhaust headers or exhaust manifolds. So the bottom joint's been done. I like to use this exhaust fire gun sealant on the joints to stop them leaking. clean up the bolts going to the headers or exhaust manifolds. Personally, I like to put a bit of copper grease on them as well, because it is some sort of steel, I guess, on aluminium. Makes it easier to remove in the future. And having the sealant on the exhaust gaskets means that it also sticks them in place, makes it easier reassembling. So just do a little bit of a bead, both sides, not too thick. It's not actually strictly necessary to use this sealant, I don't think, but personally I prefer it to get a slightly better seal. Any slight leaks make a tiny little fluttering noise otherwise. You'll notice also I've cut down these gaskets because I want all of the pressure to be around where the tube is rather than on this central part here, which can also press against the block. So with that sealant in place, we can then push it up against the engine block, line up the holes, and it'll stay in place while we pull the manifold into place and put the bolts in place. So we do that for all of the gaskets. So that's the exhaust manifold fitted. On these aftermarket manifolds, quite difficult getting these bolts in situ because they're very close to the actual tubes of the manifold. Sometimes you might need to get the spanner all the way around the back, like on these bolts, to do them up. And I actually cut down one of my spanners, so cut the end off it just so that it'll fit in the gap between the tubes, like so, to do up some of these other bolts, like so. So I've got a mixture of 3 different bolts on there, probably not strictly necessary, but just a combination of what happened to come with the manifold and what was fitted already. So that's fully tightened. Now let's do the other one. Right, next we'll adjust the valve backlash, but before we do that, let's lubricate up all of the push rods. So get an oil can, just put a little drop of oil on each of these rods, and also at the top of each rod, just so that it doesn't rattle too much when we assemble the whole thing. And you can do that when they're all slack and not in position. Let's just put that back in position. There we go. So do that on each one. Next, to adjust the valve backlash, we've got to rotate the crankshaft until number 1 piston, which is this one here, is at top dead center but on the compression stroke. And if we rotate the crankshaft, so get a 5/8 inch socket on the crank, and you can turn it round until, turn it clockwise, which is a normal engine rotation, until you start to see this number 1 valve. You see here, this end is higher than this end, so the number 1 valve for the inlet side, and you can tell it's the inlet side because this valve is next to the inlet port, whereas this side is next to the exhaust port. So that being high means that inlet valve has been opened up, which happens before you get to the compression stroke, because obviously it's sucking in fuel ready for compression. You keep rotating the crank until the marking for number 1 piston, which will be in this engine. It is a little line on the crank, which hasn't come up yet, but there'll be a line on this, what do you call it, the balancer weight or something, lines up with this little notch on the block. Let's just move that out of the way so you can see it. There's a little notch there on the block, and in a minute there'll be a line coming around. So let's keep rotating. Obviously we'll see number 1 inlet close, and what we've got to do is just look out for that line. And here it is, coming up. There we go. So there, a little white line on it as well. You can see it's lined up with a notch, which means we're at top dead center, and both valves are shut, which means we're on the compression stroke. So I've got a little dab of oil on the end of the valves, just so it lasts. By the way, the Haynes manual says to apply a moly base grease to the end of the push rods and the valve stems. If you prefer to do that, then do so. So next, to adjust the valve backlash, i.e. the play on the valve, we do up our nut until you take out all play at the push rod. So she's loads there. That'll get you down a few turns. And what you need to do is keep feeling that play until it all disappears. And by the way, this is number 1, of course, for adjusting. And when it's completely disappeared, and you can obviously check the play by moving it up and down, but also twiddling it from side to side. And when all that play disappears, you stop, and then you tighten up a further, according to the Haynes manual, further 3/4 of a turn. And do that for both of those valves. And then the Haynes says you can also adjust the valves on number 2, 5 and 7 intake valves, and number 3, 4 and 8 exhaust valves at this time. After adjusting these valves, turn the crankshaft 1 complete revolution and adjust the number 3, 4, 6 and 8 intake valves, and the number 2, 5, 6 and 7 exhaust valves. So that's one way of doing it. Another online source description way of adjusting the valve backlash is basically to set up for adjusting number 1. So then turn the crank 90 degrees, obviously clockwise, and then because the firing order is showing here 1, 8, 4, 3, 6, 5, 7, 2, you can then adjust the both valves for cylinder number 8, and then another 90 degrees, number 4, and so on. I think it's probably a little bit easier. So, and also it means the cams are on the extreme end of the lobes, so it's the ideal position for adjusting the backlash. Interestingly, this one says turn additional half turn rather than 3/4 of a turn. Don't think it really makes a lot of difference, to be honest, because they're hydraulic tappets, so they self-adjust, and it's just setting the adjustment to be in the middle of its adjustment range. So let's carry on and do that. So you can see that we're getting near to the point just about there. It's just starting to bind. Back off a little bit, you see, turns easily. One slight bit of tightening. Yeah, you can feel it definitely starting to bind there. Make sure it's not the tool affecting the rocker arm. It's just starting to bind, so another half turn, and that's fully adjusted. All right, now we'll turn the crank by 90 degrees. So 90 degrees is going to be this much, and then we'll do number 8, which is this one over here, of course, because the order is over there. We've got 1, 3, 5, 7, 2, 4, 6, 8. Keep doing that in the firing order until you've adjusted all the valves. Next, to install the inlet manifold. With this kit, we had these little rubber gaskets for sealing on the ends, whereas previously I've used solid RTV silicone seal. Put it on both sides. You have to get the inlet manifold on quickly before it starts skinning. So I've got the new gaskets in place, but a little tiny spread of silicone seal on the metal surface between the gasket. So one underneath, and I'll do the same on the top just before installing. I'm going to try these rubber ones this time to see how that goes. Looks fine. So that's the gaskets all set up, in place, and here's the inlet manifold all set up and ready to go. A little bit of a clean off. So you need to degrease the mating surfaces. I have got some of the manifold gaskets already in place, which makes it a little bit easier perhaps. Very important that these surfaces are clean and flat, so use a blade to scrape them off, and now we'll install it. Alright, that's the inlet manifold in place. Careful to lift it down as one unit straight onto it rather than slide it around too much. Check that seal is still in around the bottom. Use the camera to have a look around the back as well. Or just feel it with your fingers. And all these bolts are only in hand tight at the moment. I'll try and do it quite quickly so that the silicone doesn't go off too much where you have used silicone seal. And we've got thread sealant on the bolts because some of them open into the oil rail, so it's probably a good idea. Then we need to tighten the inlet manifold according to this tightening sequence. So sort of opening out in a sequence from the middle outwards, and doing that order according to the spec, which is, let's have a look, step 1 71 pound-inches, which is very low, and step 2 35, I guess, yeah, 35 pound-foot. Okay, that's the intake runners and the plenum attached. Just finger tight fitted the bolts from the runners to the plenum, just to make sure it's going to line up correctly when I fully tighten the bottom bolts. I'm going to take the plenum off, well, I have to take the plenum off to fully tighten the inside bolt that holds the runners in place on both sides. So the torque specification from the runners to the intake manifold and to the plenum is 25 pound-foot. So tighten those up at the bottom, as I say, at the bottom first. So before finally fitting the plenum chamber, don't forget to do up that bolt, which is right down there. And just pan out to see, so you can see where that is, right at the back. The other inside bolt's just touching where my spanner is there. Zoom out again to show you where that is. So it's just two inside ones. Also, don't forget there's a vacuum line on this one, maybe on yours as well. Slightly easier to do it with the plenum chamber slightly out like so, and then we can fit the plenum and do up the bolts. So 25 pound-foot on the runners to plenum chamber bolts. It's a bit more progress on reassembling the engine, plenum chamber, bolt start back on, alternator, the air conditioning pump, just got to do up the bolts on that one. It's useful to have photos of when you were dismantling it, and so you can see with the route where all the pipes and cables and so on goes. And so now reassembly is just a straight reversal of disassembly, and apart from refitting the radiator, which I've got some work to do on, and check out the air conditioning, then it should be fairly straightforward reassembly. And next is to flush out the cooling, try starting the engine. Okay, that's everything reassembled. Radiator, fans, all the plumbing and so on. I've got some additional plumbing pipes which I'll paint black later. Basically household plumbing pieces. This is a manual air bleed valve, just means bleeding the air out of the higher pipes is a little bit more proficient and easier. So proof of the pudding, does it run, does it start, does it run on LPG? And here it is, running on petrol. Firing on all cylinders. Okay, thanks for watching. Hope that gives somebody a bit of confidence to have a go at doing their small block Chevy head gaskets. Thanks for watching, bye.